screen and we'll get started. So again, welcome. I appreciate your patience as my technology did not want to work today. And now it's in the right place and we'll get started. So just a quick disclaimer. The content presented is the intellectual property of the South Carolina Department of Ed, SCDE. By participating in this event, attendees agree that they will not record, capture, or share its contents without permission. Attendees agree they will not use artificial intelligence to capture or summarize the contents of this event. The SCDE reserves the right to remove attendees using these services. All right, welcome. I am so glad you are here. Looks like we have a good amount of people today. I hope you brought some stuff to play around with me today. I asked if you would bring some 2-color counters or something to draw or write with so that you could follow along when we get to that part. But I want to introduce myself. If you have not yet met me, I am Dawn Hood. I am the middle level math education associate at the State Department on the standards side. And my co-pilot is...
I'm Janelle Mills, and I'm the high school education associate in the Office of Standards.
Right. If you will, in the chat, I'd like to get to know you a little bit. If you'll put in your grade level that you teach and your school and district for me, and just go ahead and throw those in the chat, and we'll see, what kind of variety we have here in our webinar today. So we got some coaches, we got some admins, we definitely got some teachers. Let's see. Marion County, I saw Richland 1, I see York, Spartanburg. Looks like a pretty good variety here. I appreciate it. If you'll keep throwing those into the chat, I'm going to go through a few little norms, some things we will use today and some we won't. I get this back to... All right, so webinar norms. So there's some things that you can use while we're in the webinar. The chat, of course, is the little chat bubble. If you want to raise your hand to ask a question, you're welcome to. Click that button. If I ask for reactions, this is where they're located. And then your camera and your mic, I've got it set where you can come off mute and talk to us. If you want to turn on your camera, I think you can as well. More actions. If we get into those other actions, I'll remind you where those are, but those are the where you can find some different things to react and maybe get to different parts of the screen. So let me see. I'm not in my office, so in my my workstation, so it makes it a little harder for me to keep going with things. All right, today's purpose. I'm gonna try to get us going here. So I want to familiarize you guys with some manipulatives that you can use to teach integer rules and how you can help the students discover those rules instead of just giving them the rules. Our learning targets are to discuss the different uses of manipulatives, what we can use if we don't have exactly what I've got here today, and some different ways to show how to do integer operations. And then we're going to practice. We're going to play around with them today. All right. Take a minute to look at this quote. And then in the chat, I'd like for you to add, how does that resonate with you today? You can either put it in the chat or you can come off mute if you feel like talking. You might want to tell me what they feel about this quote or how they feel about this quote. Using manipulatives has made a big difference in developing new learning in my classroom. Learning requires many experiences or exposures. That's two. Find it to be true, but didn't realize it would require so many repetitions. Anyone else? Come on now, we've got a lot of people in this room, and I've only heard from three. Now four, making learning fun cuts time down to learn. Learning with play helps to reduce the repetition in order for learning to happen. Hands-on definitely makes a difference. Okay. Just a quick little bit behind who the quote came from. Dr. Karen Purvis was the Reese Jones director and co-founder of the Karen Purvis Institute of Child Development at Texas Christian University in Fort Worth. She did a lot of work with helping students that were suffering from trauma. So I think she does know a little bit about what it takes to help kids get through, understand and learn this way. All right, a couple more things hit the chat while I was talking. Manipulatives make kids active. When they're playing, they're making their own connections. Interactive learning increases retention. Good. All right. Next up, let's talk about some of the best ways to engage students. You can come off chat, come off mute, or put it in the chat. What are the best ways to engage students in the classroom?
To have students complete hands-on activities. When they're able
Absolutely.
to touch and feel it, it requires them to almost use all their senses to be able to interpret and understand math.
Absolutely. Fun and relevant to their lives. Bring it to life. All right, let's think about classroom specific. What other things in the classroom will get them engaged? Using manipulatives, math discourse, turn and talks, learn by discovering instead of feeding it to them. All right, those are some of the ones I was looking for. Allow students to participate in the lesson by using their hands, sight, hearing, and talking with each other. Wonderful. So I had thought student discourse. And so you can keep going. I like looking at what you're putting in there. Then I said, get them up and moving. You said that. So far those two are in there. Collaborative activities. I think I saw that. Making activities relevant. I know I saw that. Giving students choices. Not sure I saw that one, but that's another option. And then using manipulatives absolutely was in there. So what's our common theme? I'm looking at these bullets and what you guys were putting in the chat. What's the common theme?
That it's student centered and they're kind of guiding the learning.
Absolutely. Good job, guys. Movement, collaboration, student centered, all about the students and trying to get them involved in it. Oh, I skipped one, sorry. All right. Moving on. So what are math manipulatives? We're going to use the waterfall protocol here. If you don't know what that is, then hold on. In the chat, you're going to define math manipulatives, but don't hit until I say go. So don't hit send until I say go. So give me some ideas. You can do more than one, but what are math manipulatives? So in the chat, go ahead and type your answer. Give you a couple more seconds to get that in, and then when I say go, I want you to hit send. Or enter, either way. All right, go. Any hands-on tools that students can have. Let's see, my answers keep going away. Items used to help students understand math, hands-on tools, any object used to represent a value. Tools, I keep saying tools, and students, and counter shapes, fraction tiles, clocks, hands-on tools, concrete tools. All right. So Prodigy Math, sure some of you know what that is, but their blog describes manipulatives as objects, charts, and activities that engage learners while helping them develop their math skills. Pretty sure that that was in everything you guys said. All right, so why should we use them? Why should we use math manipulatives? Who wants to answer that one?
It helped with conceptual understanding.
Good. It allows the repetition that was stated earlier. They help kids see and feel the math. Help students make meaning of the concepts, understand concepts more easily. Absolutely. I know that when I first started trying to use manipulatives, that they were intimidated. I was very intimidated by manipulatives. So I tended not to use them except in very controlled circumstances. So as I evolved as a teacher, I started doing things differently. I started making sure that the kids had access to manipulatives whenever they needed them. So I'd put them out, I'd put several out around the room. They had stations, they knew where to go find them from if they needed to, but they always had something at their tables to be able to use if they needed to put their hands on them, even if it was just a bunch of pencils to count with or to work with or something to draw with. So I know that they can be intimidating for all teachers. The most veteran teacher could be intimidated by manipulatives they have never used before and don't know how they fit with something. So I'm hoping that with this series that I'm going to do with several different types of manipulatives, it'll help you guys get a little bit more comfortable. All right. I feel like it keeps doing the same thing over and over again. All right, so how can we use manipulatives in the classroom? So what different ways can we use them? We're looking for uses that can happen. So, I'll mix up in my words here. So what you can do is use them at the beginning of the lesson. They can be used during only part of the lesson. They can be used for enrichment, reinforcement, remediation, or a tool that students can use whenever they need them. And then as students get stronger using the concrete pieces, then they can move to that representational piece where they can draw what they need. All right, y'all ready to play? We're going to look at using two color counters with our integer operations. Now, give me a second. I didn't quite get organized when I came back in here. So let me get all my parts together. So I'm hoping that you'll be able to see the document camera that got set up. Can y'all see the table here? Yes, no?
Yes,
All
they
right,
can
see
see
some
the
yeses.
table.
Thank you. Thank you. All right, so we're going to start off doing a few different problems. So you may want to write these down. I've got them on actually Janelle's going to drop a a link to this worksheet in the chat for you. She's already done that. And you can pull up the problems that we're going to work through to help with that discovery process. So we're going to start off with addition and subtraction, and we're going to use 2 color counters, and then we'll look at some number lines for that, and then we'll look at multiplying and dividing afterwards. Okay. All right. So give you another second or two to pull it up. But our first problem is going to be just +3 plus +4. To model that, you want to show the students that we're going to use yellow to represent positive. We'll use red to represent negative. Okay. So if I have +3, I'm going to start off by showing 3 yellow counters, and then I'm always adding to my table. So my next step would be to add in 4 more positives. And so I would have the students complete this problem, write it out, and then on their paper, they would want to write what their answer would be. Sorry, like I said, I had to move a couple different times, so I'm trying to get everything where it needs to be. So 3 plus 4 would equal 7. They could draw it out if you wanted them to have both the drawing and the manipulative, but I would focus on just the manipulatives first. Okay, so we're going to go down the left side. So the next problem is 3 plus -4, or we can read that as 3 plus the opposite of 4. Because when we see a negative sign, we can say the opposite of. So that helps with what we have right here. We have 3 and we had +4, but the opposite would be to flip it over. And so they can discover what to do here. They can think about, okay, if I have 3 positives, 4 negatives, and we've talked about what a positive and negative can do. We know that that would be a 0 pair, another 0 pair, another 0 pair, which just leaves me with 1 left over. So 3 plus -4 would be a -1. And just writing the answer down there. Now I would do all of these with them before you start talking about any kind of rule. So then the next problem is -3 plus 4, or the opposite of 3, which is -3, and then our 4 positives again, the original. So using the same numbers, it helps them see the connections. And then again, our 0 pairs put together. So now our answer is just +1. And you can do several different addition problems, use different numbers and have them start seeing what's happening. But I would go through all 4 types of problems each time. Okay, so then the last problem is -3 plus -4, or the opposite of -3, or opposite of 3 plus the opposite of 4. And we're going to show them the 3 reds and the 4 reds. All of them are the same, so we can combine them and get an answer of -7. So as you're doing these problems, you want to ask the students, what do you notice? What do you wonder? Do you see any patterns? Some of them, of course, are going to get it faster than others, but you want to make sure that they're seeing those connections. If they're not seeing the connections, they're not seeing the pattern, then do another set of problems. Change the numbers up so it's different numbers and let them see what happens. What did I do when I had more positives than negatives? What happened when I had more negatives than positives? And let them see, oh, I see. My answer was negative when I had more negatives. My answer was positive when I had more positives. Okay. Now, when we get to the subtracting, that's a little bit different. Takes a little bit more thought. So we're going to start with putting down for 4 minus 3. I'm gonna put down 4 yellows. And I can say 4 take away 3. I'm gonna take away 3, which leaves me with 1. They should remember how to do this from elementary. Okay. But the next one is where it gets a little confusing. Okay. So they've got 4 positives and they want to take away 3 negatives. And you're going to tell them, I don't have 3 negatives to take away. So how can I do that without changing 4? This is where your discussions with your 0 pairs is going to come into play. And they're going to have to see that, okay, if I put up a 0 pair, this is a 0 pair. I've not changed this number at all. It's still 4 plus 0. So I still have 4. I'm going to add another 0 pair. I still don't have enough to be able to take away a -3. So I need one more 0 pair. So if I want to take away 3 negatives, I've had to create 3 0 pairs. I still have the number 4, and I can now take away 3 negatives. When I take those away, what's left? 7. So I have a +7. This is when the doing repetition of these problems will help them figure out that pattern. All right. The next one was a -4 minus a -3. So that one's very similar to the first one. -4, I can subtract, oh, that was the bottom one. Sorry, I'm skipping one. So we want to jump down to the bottom one, -4 minus -3. That one's just like the first one where we can just take away 3 and be left with a -1. The -4 minus the +3 is like the one we just did. They're going to need those 0 pairs again to be able to show taking away a +3. Can't do that without creating 0 pairs first. Subtraction is a little harder for them to get before they just figure out that rule and how things work. Because we don't want to necessarily say, all right, we're going to add the opposite every time. We want them to see why that works before we start talking about that algorithm. We want to get that conceptual understanding as to why those 0 pairs help out. Because this number is still -4. Now, if I take away that +3, that gives me the total of -7. Again, those, what do you notice? What do you wonders? Can go on there. All right. How do we feel so far? You want to do any more problems like this, or you want to go to the number line? Hear anything, so I'm going to move to the number lines. All right. I got a couple of number lines on the sheet.
We have one more, Dawn, show one another.
Show another?
Yes.
Okay. All right, let's see. Let's do, we'll do negative or +5 and -5. Let's see, 5. Do you want to do subtraction? The one, show another with subtraction or addition or both?
Both.
So let's start with 5s and 2s. All right, so if we're going to do positive, we'll do the same series of problems. +5 plus 2. Or you can put the smaller number, well, we had the smaller number first before. So +5 plus 2, of course, would be easy. Just add 2 more. 5 plus 2. But 5 plus -2. Okay. So we've got -2. You can do it that way and show that those 0 pairs come together. So we have 3 left over. Let's see if I can get this. So we had 5 plus 2, 5 plus -2. So that was 7. This is 3. All right. Then our next was a negative plus a positive. So the opposite of 5 would be the red counters. Or if they don't have counters, guys, you can just have them do, okay, -5, draw 5 circles with a negative in it. Okay. And then 2 positives go with it. You can always use red and yellow paper, black and white paper. So the question I see now is, how do you know to make a zero pair? Hopefully the zero pairs come up while you're talking about absolute value. You're talking about integers on a number line. So you should have already discussed zero pairs before you get to the integer operation rules. Or integer operations, I should say, because that should come up when you're talking about opposites on a number line. And so you just have to remind them, what do we know about one positive and one negative? We know that they are opposites, and so that they would make a zero pair. So if I have -2 and +2, that is opposites, and they will be 0. So that leaves me with 3 negative pieces. And then the last one would be -5 plus a -2, which is very similar to the first problem we did, where they're all the same and we combine them together. Okay. All right, Angela, we're getting there. All right, so you want to see 5 minus a -2. Okay. So if I have +5, I want to subtract -2. There's 2 ways you can think about this. You can think about minus a -2. You can think about the opposite of -2. And the opposite of -2 would be +2. Remember, negative sign is always opposite. Even if it's a subtraction, it's still a negative. Or you can say, I want to subtract 2 negatives, but I don't have 2 negatives. I only have 5 positives. So how can I subtract 2 negatives? I can add a zero pair. If I add a zero pair, I need 2 zero pairs in order to subtract those 2 negative pieces away. So once I take those away, that's how I get my +7 for that problem. So there's 2 ways to think about that. Subtracting -2 by adding zero pairs, or it's the opposite of -2. Okay. All right, ready for number lines then? We're going to do multiplication next after number lines. So let's hit some number lines. All right. Go back to, I can get there. Here. All right, number lines. We're going to do the same thing. We're going to look at the camera and we're going to talk about how we can use it on the number line. Let me put that back up. There. Okay. Now, see if I can get a little higher up view. It's making it harder to there. All right. So if we're doing, let's say the 5 minus the negative, or we'll do 5 plus 2 and do 5 plus. Y'all can't see this anyway. So we're going to do 5 plus -2. Then we're going to do -5 plus -2. -5 plus a +2, because I'm pretty sure we know how to do 5 plus -2. I mean, 5 plus 2, sorry. All right, so moving on. 5 plus -2. So I'm going to start with 0. I'm going to make that jump to +5. That's +5. And then however direction you want to go from there, if you want to change colors. To go backwards 2, because anytime we have -2, we're going to move to the left. Positive will move us to the right. So I can go back -2. It's real hard to see on these small number lines, I know. And that gets us back to 3. So 5 plus -2 would be 3.
Can you pull the number line down a little so they can see the original problem? Thanks.
All right. So 5 plus -2, we went to the right 5 because it's positive, and we moved to the left 2 because it was negative. All right, so the second problem we'll do -5 plus -2, which would just move us to the left 5, and then 2 more to get all the way to -7. And the last problem, -5 plus 2. Okay, so which way are we going to go first? First number is negative, so we'll go left to -5. Now, if I'm adding +2, go underneath this time so you can actually see what I'm doing. So that gets me back to -3. Okay. So how do you feel about number lines? I feel like the number lines are almost easier when we're talking about adding and subtracting because it really shows the direction we're moving. Do you want to do any more number lines, or are we good with number lines? Ready to move on to multiplying and dividing? Yes, vertical number lines are also great. Thank you, Tammy. Good with number lines. Right, good? Go ahead and clean them off so we can use them later. All right, so moving to multiplying and dividing. Chanel's going to drop in that sheet for you. I'll put it over on my side so I have it. You want me to do -5 minus 2, or is that, Francis, is that? Yeah, so you move to -5 and then move 2 more to the left. Oh, we didn't do subtraction on the number line, did we? Okay. That's, I think, what Francis was asking about. For subtraction, 5 minus -2. So our subtraction problems, if we do, let's do 5 minus -2 first, then we'll do -5 minus -2, and then -5 minus 2. Okay, so those are 3 problems. So starting at 5, so 0 to 5, +5 moves us this direction. Okay, now this is where it could be complicated. Because when we're subtracting, which direction are we going to go? We're going to go to the left. But this is not a +2, so I can't just go to the left. This is telling me to do the opposite of that. So instead of going left 2, I'm going to go right 2. And get me to +7. So the opposite of this. That makes sense? So for -5 minus -2, we're going to go left 5. So -5. And because they're the same, we could just say we could keep going to the left. But that's not going to quite cut it because we want to do the opposite. We would go left 2 more. Because instead of going back the other direction, we're just going to go left 2 more. No, that's not going to work right. Sorry about that. The opposite of is what I said, right? So instead of the opposite, here we went the opposite. Instead of going left, we went right. So instead of going left, we need to go right 2 more. So that would put us here at -3. All right, so can y'all hear me now? Okay. I don't know what happened. My computer has a gremlin in it, I swear, because it just muted me. So if a student is, if you're doing like a human number line, which we're going to talk about in a second, actually, but we'll keep going. But if they're adding, they're going to move to the right. If they're subtracting, they would move left. But they would have to turn around and go that direction if it's negative. So negative means opposite of, so they would turn their direction around. Hope I'm not confusing everyone. All right, so -5 minus 2. So I'm going to start by going left 5. That's -5. And I'm subtracting a positive number so I can continue going to the left 2 more places. So another -2. Where here, we had to turn around and go the opposite direction because of the 2 negatives. So we had to change and go the opposite direction. Same thing there. Okay, does that help? Back to the PowerPoint. Point, number lines. So like I was saying, with walking the number line, help students to discover these rules. And Janelle's going to drop a link for that sheet in there too. You'll want to set up in a hallway or move some desks around and create some number lines on the floor for the students. I know these are elementary kids, but it's the best picture I could find with them walking on a number line. So you don't necessarily need a number line, but they can count out loud to find their solution. They just need to know where their 0 is. And so you can do it on the floor with a piece of tape as their 0, and then use the tiles on the floor as their numbers. And so they can count, they could go forward 5 places. So to the right, forward, or which it doesn't matter which direction they're going from their 0, as long as they're going forward for positive and addition, and then they would go backwards for subtraction, and a negative would tell them to turn around. So they would go forward 5 places for 5 minus -2. And then for subtraction, it would tell them to go backwards 2, but because it's a -2, they're going to actually turn around and go the opposite direction 2. So instead of going backwards 2, like we did on the number line, like we would have on the number line, they would have gone forward 2. And so the directions on that sheet give you all those steps for adding and subtracting. I've got a little note for myself in here that just to have you guys make sure you go through some of those problems with your students, model a few together, like do several together from each problem set, and then ask them those questions. What do you notice? What do you wonder? And they'll start figuring out all those little rules before you even have to give it to them. They're going to figure out that two positives, of course, is always going to be positive. Two negatives will give a negative answer when you're adding, and so forth. All right. Other possibilities. What else can we use to teach integer operations? We're going to do multiplication and division. I think I skipped the slide, but we'll do those in just a sec. But what other things, what other manipulatives could you use to teach adding and subtracting? I see money. Everybody wants to say money because you can't talk about money. They get money, that's positive. They have to give it away, that's negative. And that's something we really hope that's near and dear to their hearts. Sea level, temperature, those vertical number lines out there, football yardage. Above ground, underground. Uh-huh. All right, while you are adding those in, I'm gonna try to get the camera back up. There we go. And let's do some multiplying and dividing. So Janelle, if you hadn't put that one in there for me, do that for me, please, ma'am. And we're gonna start off with the left side. 2 times 5. I'm gonna try to get the camera back up. There we go. And let's do some multiplying and dividing. So Janelle, if you hadn't put that one in there for me, do that for me, please, ma'am. And we're gonna start off with the left side. 2 times 5. Tell me what multiplication means while you're getting your counters ready or your papers ready. Did the recording stop? It's still recording. Groups of
Yeah.
repeated addition. Okay. All right. So we want to think of this as groups of when we're talking about multiplying with negatives. So 2 times 5 means 2 groups of 5. It's positive 5, so I want 2 groups of positive 5. So show my 5 and 2 separate groups. So 2 groups of positive 5. Okay, would be positive 10. How would we do it with the second problem? 2 groups of negative 5. Just have them do red counters. 2 groups of red. And again, you could draw positives and negatives on paper, but it's always fun for them to be able to flip them over if they can. Okay, so those 2 are the easy ones. The next one, negative 2 times 5. What does that mean? You could turn it around because we could use commutative property and say 5 groups of negative 2. But what it really means is the opposite of 2 groups of positive 5. So what's the opposite of 2 groups of positive 5? 2 groups of negative 5. That word, that negative sign, the opposite of is that key. So 2 groups of 5. This is the opposite of 2 groups of 5. So 2 groups of negative 5. The opposite of that. Okay. So that helps with that last one. The opposite of 2 groups of negative 5. So we're saying the opposite of 2 groups of negative 5. I know that's hard to read. See if I can make that nicer. So take that negative out of that first one. The opposite of 2 groups of negative 5. So if they do 2 groups of negative 5, what's the opposite of that? And they flip them over. Okay. So negative and come out at 2 groups of 5. The opposite of 2 groups of 5 is negative counters. The opposite of negative counters would be positive. Right? So then moving to the division is the same way. 9 divided into groups, 3 groups. So if I have 9 counters, I want to divide them into groups of 3. And it's all about what we know about that 9. Okay, if that 9 is negative, we're going to divide them into 3 groups, 3 equal groups, 3 in each group. Okay. 9 divided by negative 3. So I still have my positive 9 counters. And it's that the opposite of again. Okay, we can pull that negative out and say this is 9 divided by the opposite of 3. Okay, so if I'm going to have the opposite of that, then that would give me the negative 3. Then pull it out again here. Negative 9 divided by 3. Oops, should have 2 negatives in it. So the opposite of, this one's really the hard one. The negative, I know you'll see what I'm writing over here. So this is really the harder one to say, because you're saying the opposite of 9 divided by the opposite of 3. So what's the opposite of 9? Which is negative 9 divided by the opposite of 3, which helps you get to that positive groups. Or the easy way to say is, how many groups of negative 3 are in negative 9? Okay, so how many groups of negative 3 are in negative 9? So you just want to have your 9 counters. How many groups of negative 3 can I have out of that 9? So it feels like the division wasn't as hard to talk about as it was when we were talking about these over here. All right, well, I'm rushing till the end, of course, so let me get through. We already talked about that. What other questions do you guys have for me before we move to the feedback for today? And I apologize again for being a little bit late getting started. Technology problems today, and we even tested this morning and it worked just fine. So I guess that's what happens when you have things going on during the day. All right, please feel free to drop your questions in the chat. I'll hang around if you have any questions after this, but let me go ahead and get y'all started with our survey for today. I think Janelle put in the name of